Namaste, good morning. New topic, that is SR flip-flop. In last lecture we have studied latch, what is latch and what is flip-flop. You might know the little bit difference between latch and flip-flop. Latch without clock pulse and the flip-flop with clock pulse. So, we have studied latch using NOR gate and latch using NAND gate, and today we are going to see the SR flip-flop, means the latch with clock pulse. So, see here a few definition. Clock pulse is used for synchronizing the circuit as an additional control input. Here is the circuit we have drawn using the help of 4 NAND gate. You must remember, this is a NAND latch in which the NAND gate is latched here. Just we have added these 2 NAND gate for extra as a clock pulse. So, we will see further. Second point, in a clocked flip-flop, the output can change state when the clock is high. When the clock is high, on that time the flip-flop changes the state. When the clock is low, the output remains in the same state, means there is no change. If there was 0, then 0, if 1, then 1. This is the main point. And the next point, we want a control to change output in subsequence, that is known as clock. Because you know already in latch what is happening, there was no control, just it was moving according to the 1 and 0, 1 and 0, 0 and 1. Here what is happening, we will give the clock pulse. When the clock pulse will be the high, only on that time the state will be changed. If the clock pulse will be low, on that time the output will not be changed. Whatever inside, that will be remain the constant. So, starting first of all the C, here is the truth table of NAND gate. I have made already due to save the time. So, you remember the NAND gate of the output is y is equal to a dot b whole complement. So, if the input is 0 0, the output will be 0 into 0 is equal to 0 and the complement of 0 is equal to 1. So, this is the 1. 0 into 1 is equal to 0 and the complement is 1. 1 into 0 is equal to 0 and the complement is 1. 1 into 1 is equal to 1 and the complement is 0. So, this is the truth table of our NAND gate. And we have used this. We see if one terminal of the NAND gate will be 0, so this and this 0, and one terminal of the NAND gate is 1. So, I have made like this. Now, see what is happening here. If this is the NAND gate, suppose this is the NAND gate here, and this terminal is suppose 0, this is A and this is B. If this is 0 and we are putting here 0, then output is coming 1. If this is 0 and we are putting 1 here, the output is again 1. So, that means what is going here, if one terminal is fixed by the 0, then other terminal what may be, it may be 0 on 1, there is no effect, there is only the output is 1. There is the output is only 1. But in the next another position, see, if the output is 1, one terminal is fixed by 1 and the another terminal is 0, this is 0, then what is happening? The output is coming 1. And if again this is fixed by 1, another terminal is 1, then what is going? It is changing by 0. So, what is happening? It is very interesting. When the clock is now, we will put 0. When the clock pulse is 0, and suppose S is equal to 0, R is equal to 0, what will be happen? In this circuit, there is the two circuit. One, this is the latch, you already know. This is the NAND latch. The truth table of NAND latch I have written here, when S is equal to R is equal to, and the next state Qn plus 1, when 0 0 and valid 0 1 set, 1 0 reset and 1 1 hold. This is the truth table of this latch. We have already studied in the last lecture. If who have not studied, please go and see that last lecture. That was the SR latch using NAND gate. Now here, if S is equal to 0, R is equal to 0, clock is equal to 0, we have already seen that if this is 0 and this will be the 0, whatever the another input will be, the output will be always 1. Here also, if the input is this is 0 and R is equal to 0, again this is 0, this will be also 1. And when suppose I am putting the name here S dash and R dash, so the 1 1 is here. What we are seeing here, if S is 1, R is 1, that will be the hold condition. So, we can write here, this is the hold condition, and hold condition means what? Whatever was on the Qn, that was 0 to 0 and 1. So, we should write Qn. Whatever was the output on the last time. Again, if clock is equal to 0, S is equal to 0, R is equal to 1, what will happen? S is equal to 0, R is equal to 1. See here. Now again the one terminal is fixed. This is 0 0 because this is the clock, and this is equal to 0. So this is 0. The output is always 1 because I have told you if the one terminal will be 0, then output is 1. Here again, if the this is terminal is 1, so the output is always 1. So 1 1. Again, what we are going to see? When S is equal to 0, R is equal to 0, 1 1, and the 1 1 is here, the hold condition, again this is equal to Qn, and we can say, right, this is the hold. So, what we are going to see, if the clock is 0, always the output will be 1 1. So, 1 0, 1 1, if the clock is 0, this always this will be the Qn, this will be the hold state. So, this can't work, because we need clock should be always 1, then only it will change the state. Else, if clock is low, this circuit is not changing the output. So, we can write direct this by, if the clock is 0, whatever be the S is equal to 0 or R is equal to 1, whatever the state will be the Qn. So, I am rubbing this all the 4 state condition will be in the 1 by using the don't care. You already know the don't care means 0 or 1. So, here is the use of don't care. We have also studied in the last lecture don't care. So, if S is equal to 0 or 1, R is equal to 0 1, if the clock is 0, then output is always the Qn next state, and that is the hold condition. So, now let us see here. Now, what will happen? We don't like this condition, we like always the clock should be the 1, always the clock will be 1, this, always the clock should be 1, then only the output will be changed. So, if the clock is 1, S is equal to 0, R is equal to 0, means this is equal to 0, this is 0, what will happen? This portion is 1 and 1, because due to the here the clock is 1. So, S is equal to 0, now by the help of this truth table, suppose this is 1 is fixed, 1 point, 1 terminal, and another is there, if it is 0, then output is 1, 1 is 0. So, here is the, if input is 0, so the output is equal to 1. Here also the input is 0, so the output will be opposite and 1. And if when the S and R, S dash and R dash I have written here 1 1, we will see here this will be the hold condition. So, this will be the hold, and the hold means Qn, the last whatever the input output was here, that was the Qn. Now, the next condition, when clock is equal to 1, we can also say the trigger, and S is equal to 0, R is equal to 1, S is equal to 0, R is equal to 1. So, what will happen? If this is 0, again this is 1. If this is 1, now this will be the 0. Or when S is equal to 1, R is equal to 0, by the help of this SR last table, we will see here, if this is equal to 0 and 1, this is known as the set condition. If the 1 0, that is the reset condition, sorry, 1 0, this is the reset condition. So, we can write here 0 and you will write reset. Okay, you are understanding? Very easy. Now, the next one, when S is equal to 1 and R is equal to 0, clock is always 1 again, S is equal to 1, R is equal to 0. Let us see, S is equal to now here 1, this is 1, the output will be changed, and here this is 0, output will be 1, because you have seen in the latch table. And S is equal to 0, 1, we will see here this is 0 and 1, S is equal to 0, R is equal to 1, set condition. So, we will write here, and this is the set condition. Now, the last one, if S is equal to 1, R is equal to 1, again this will be 1. So, here will be the 0, here is 1. So, it will be the 0, and S is equal to 0, R is equal to 0, already know what is happening, invalid. So, if this is 1, this is equal to 1, and this is 1, this is this here, and here it came the 0, 0, and this is invalid condition. Invalid condition. So, we have seen the latch by NAND gate, additional circuit, that is the clock. So, this is known as the flip flop, SR flip flop, and this is the truth table of SR flip flop using NAND. And what we are seeing here, when the clock is 0, nothing is happening, that was in the hold condition, whatever the last position, that was the fix. But when the clock is 1 and S input is S and 0 is equal to 0, 0, then it was the hold condition. If clock is 1, input is S and 0 and 1, then it is the reset condition. And if clock is equal to again 1, S is equal to 1, R is equal to 0, then 1, that is the set condition. And if the clock is 1 and S is equal to 1 and R is equal to 1, and that time here is the invalid, because what is the invalid means, here is also 0, here is also 0, because you know already here is 1, then this is also 1. So, this is the invalid condition. By this way we have seen. Now, we will learn SR flip flop using NOR gate, and what we will see the difference between SR latch. You have seen that in SR latch using the NOR gate and SR latch using the NAND gate, that was the truth table was totally inverse. This is the inverse. But in this flip flop, when the clock is applied here, we will see by the help of NAND gate or NOR gate, the table will become same. So, we will see in the next lecture. It is very interesting. After that, we will study the JK flip flop, because here is also the one problem is coming, because when the input is 1 1, on that time there is again the invalid condition. So, how this condition will be solved? So, we will see the further in the JK flip flop. So, till now today this much only. Have a good day. Bye bye. Share our channels, like and study very well. Best of luck. Namaste. Bye bye. Thanks.